Okay, so I'd like to welcome Stuart Herbert, who will be introducing, again, Storyplayer. Thank you.
Good evening, everybody. How are you all? It's been a long time since I've been here and talked. It's actually been 3 years. Just get this sorted out, and then we'll be up and going. Perfect. Right then. So, here we go. So 3 years ago, when we were over at Google Campus, I actually came out to PHP London. And I talked about Storyplayer, which is an open source tool that we just open sourced when I was working at DataSift. And fast forward 3 years, and they were kind enough to invite me back, and I wanted to share a war story about Storyplayer, because I want to show you how you can use Storyplayer to ship faster. So this is a war story, right? And every good story needs a cast of characters. So let me introduce our cast of characters to get started with. So I'm a great believer that good software development, good computer programming is applied science. But very few projects are this well organized or have any sort of diversity like this, I'm afraid. This is a bit more of what most teams are like, including the team that I'm going to be talking about today. And if you want to know more about my philosophy about science with programming and applying it, I did a talk for PHP Berkshire last year called The Mad Science of Testing. Slides are available online. Recommend you go read that. But the team isn't the real hero of this war story. The real hero is Storyplayer. It's available via Packagist, easy to install via Composer. You can get up and running in no time at all. I'm going to show you how to do that as part of today. That's going to be our hero. Now, every story needs a villain. My choice of villain is time. It'd be easy to pick out people. Management's always an easy one to pick on. But for me, time is actually the real enemy of software development. Now, I don't know how many of you agree with that, but why would you think that time is the enemy? Anybody? We do have some microphones down here at the front.
We're most probably running against the clock on everything, isn't it? For example, any sort of issues that come up, you need to resolve them before you progress further.
Okay. Yeah. Anybody else want to say? Sorry, we've got microphones because we're recording tonight, apparently.
You cannot control?
You cannot control time?
Yeah.
Okay. No, that's true. None of us have TARDISes yet. Live in hope. Anybody else?
We never allow enough time for the hard bits. We always plan for the easy bits and expect the hard bits just to happen somehow.
That is a very good answer. I've worked on many projects like that. For me, the reason for time is the enemy is because of the way the landscape is today of our industry. Many years ago, I was doing web development for a well-known firm that no longer exists, sadly. And at that point in time, to do software development, each developer in the 15-man team had a development machine on their desk that cost something like 20 grand for the hardware alone. This is on everyone's desk. The software licenses on that machine were another 20 grand, give or take. The production environment cost so much, it came with a team of 24/7 support, a team of 4 people permanently on site at our office. That's what it used to cost in the dot-com boom and bust days to run a website. Now you compare that to something like DigitalOcean today, where you can get up and running for what, $5, $10? Your hardware is commodity hardware. You can go into Dixon's Curry's, buy a laptop for 300 quid and you can be up and running. You can do development on it. Or you can buy a Chromebook or something equivalent, or a Mac or say. Your software is free, especially with JetBrains giving out their licenses. But Sublime Text is very affordable, Atom's free, NetBeans is free, Vim has been free forever. The costs have changed, and now time is what costs the most. Every time the clock ticks, cash is being burned in your business if you work for a company. And any of you are managers and you've got to help meet the payroll, you'll know exactly what I'm on about here. And what has happened in today's industry, which has completely changed from 15, 20 years ago, is the time it takes to design and deliver working software is now the biggest cost to most businesses. And the emphasis there is very deliberate. It's not just about writing code, it's about figuring out what code you've got to write. It's about making sure it works so it sticks, so it can earn money rather than cost you money. That whole timeline now is our biggest cost in the software industry for most firms today. That's why I've picked time as the villain of this story. What are we up to? What was the team up to? What did we need to achieve as a team? This is all the backstory for why Storyplayer helps you ship faster. Here's the technical architecture. Names have been withheld to protect the innocent. So we were brought in to look at an internal payment system. There was end user systems, these public services that the customer used. Customer's browser would connect, and in order to make use of these services, they had to pay up some money to do so. API calls would be made to the internal system, and then for PCI DSS compliance, rather than take the credit cards ourselves, goes out to third-party payment providers. Everything's driven by the user's browser. If the user's browser doesn't connect to a system, nothing happens. All these boxes are passive. And if you think about PHP and its architecture, it's not an application server like you get with J2EE or with Ruby. Oh, that's a common pattern there. PHP is all about request-reply services. That's its strong point. That's what makes it really good. But if the user's browser doesn't connect to any of these services, nothing happens. And a specific scenario is the user's browser goes off, fills out the credit card form, pays the money. Instead of coming back, the user closes the tab on their browser. So the user's browser does not come back to the service to say, hello, I finished my purchase. And because the user's browser isn't triggering any activity, nothing happens. Money's been taken, but the right to use the product and service is not released because the payment hasn't been confirmed. Now, this architecture diagram is also incomplete. There's an important actor that's missing from this initial architecture, and that's the banks. How many of you have worked on payment systems? Okay. So hopefully you're familiar with the life cycle for direct debits and dealing with that. So for everybody else, the bank is actually the source of truth in a payment system. It's not your system. Your system's trying to catch up with what's actually happening at the bank. The bank and the bank account, which is where money is actually the source of truth. And what happens with banks is they've got their own life cycle going on. They're active systems. And they are sending messages out to payment providers to tell the payment provider what has happened. So a direct debit, for example, you might set up a monthly subscription. So every month the bank will send a message to say, hello, this subscription's gone through, money has been taken or not. Okay? And there needs to be a way to solve our quest for that information to come through to the payment service and out to the public service so that the customer continues to have the right to use the product. But our two actors can collude. As a user, you can go to the bank as an account holder and say, I want to challenge this payment. Don't like this, don't like the look of this on my statement, or I'm not happy with the service, I want my money back. You have the right with a direct debit to cancel it at any time. You can suspend a direct debit and resume it later. It also turns out you can move a direct debit from one bank to another as well. And these are all things where the user is talking to the bank and not talking to you. You've got to find out about these things. So we were brought in to fill in these blanks. That's what the team was brought in to do. We needed to add active components to the architecture. We need to add an active system to check what was going on, find out what messages had been sent from the bank to the payment provider. And then we needed a system to turn that into notification events to send out to the public services so that they would keep their own records up to date about who had the right to use what and who hadn't. Because the users don't interact directly with the payment service. It's purely an API-based system. Get that done, job done. That was the goal of the project. That's the quest. So where is this war story happening? What's the battlefield? Architecturally, it's quite simple. There's no surprises in here. There's a payment service. It talks to the payment providers via their API, but again, it's passive. It's using MySQL to store state, and there's an official API client for the public services to all integrate with to save them having to reinvent the wheel all the time. It's all done in Zend Framework 2, very straightforward, very boring. For payment gateways and payment services, you want boring. You really do. That's what customers are paying for. So our job was to add a notifications API, a notifications module to the payment service, and to create the notification system, which we decided to do by spinning up some queue workers that would write to queues that the public services would drain. Queues are fantastic, by the way. I don't know how many of you get to play with them, but if you've got asynchronous events happening, use a queue to communicate. You decouple the performance of services, you decouple their relative load, and unless you need real time, queues are brilliant. If you need real time, you have to get a bit more creative. We also had to fill in a blank on the testing side. We needed to introduce Selenium Grid and use Firefox to do some testing, UI testing as well. Very straightforward stuff. And although we didn't know it at the time, the other thing we needed to do was deal with the fact that traffic has to go through an outbound proxy. One of the standard techniques you do if you're running production infrastructure is you assume your servers are going to get compromised, so you limit what those servers can talk to, including the wider internet. So if someone breaks in, they can't go any further. The value of that break-in is relatively limited. So that means everything that the payment service API can do needs to go through support going through an outbound proxy in order to be allowed to talk to it. And the outbound proxy has a whitelist of what servers it can and can't talk to. Very straightforward. In code terms, version 1 was live. Version 2, being worked on by a different supplier, was in development. Version 2, backwards compatible with version 1 and was due to be released shortly, and then that team would roll off. So we took the decision, rather than try and patch up version 1, because version 2 was imminent, put our work into version 2, it will go live, the customer will be very happy because they get lots of new features, lots of stability all at once. This was the pitch we made end of October, early November. The word came back, yes, we want you to do it, but you've got to do it by Christmas. Which last year it meant the work had to be done by December the 18th, Friday, December the 18th. Where Christmas fell, everyone took a fortnight's holiday. We had to do that with a team with no full-time developers. There was three main people on the team contributing code, but I was also the technical architect, so I was liaising with the business analyst and with the business to understand that their needs were being met. I also had to work with other suppliers as well for integration purposes. The other 2 developers on the project were also DevOps people, so they were spending time spinning up the infrastructure required to support this as well. So how do you feel about that for a challenge? How many of you would be up for that? Roughly 6 weeks, 3 people. This chap was actually on the team, by the way, so not a lot of confidence there. We decided we could do it, and we took it on. The first thing we did, anything you do when you're fighting the war, is you want a base of operations. You want somewhere solid that you can start from. You need to establish a beachhead if you're invading someone else's territory. And if you're working with an API server, first thing to do is get authentication working. Stand up the server, make sure you can run the code, make sure it's got a repeatable data set to start from, and make sure you can authenticate. Because if you can't do that, all the new APIs you're adding to the API server are just going to reject you anyway. So it's the first thing to do. And what we're going to do with this in this section, we're going to go into the actual tests in detail to show you how we use Storyplayer to do that. Such a deadline, we needed the right tools to do it. So here's a story that we implemented. Changed the wording a little bit, but it's got the right sentiment. So a scheme user is the internal name in the company we were supplying to, our client, for a user on the public service. Each of those have their own user, just like Unix services do that login. And we use a HTTP request, get a new token. Very straightforward, really easy to do. enter our hero, Storyplayer. We wanted to get this up and running and actually write a test as if we were one of the public services to prove that the API was running and that we could actually do the authentication. Now, so I'm going to actually show you what the test looked like. The first part of a Storyplayer test is just a little stanza to explain what it is you are doing. You can end up with hundreds, sometimes thousands of tests, depending how deep your test strategy is. So we decided to do this. And we also, Storyplayer's moved on since I first came here and announced it. It's now on version 2. So it's important to tell Storyplayer which version you want to be compatible with. So our story, this is a precondition. We're saying we want to be a certain person before we run our test. In Storyplayer terms, what we do there is we add a test setup phase to say, okay, I'm going to create these preconditions. I'm going to make sure they're satisfied so that my test will run reliably. And this is what our test setup looks like. Hopefully you can read that at the back. And we'll go through that in detail. So the first part is we want to load a user. And we load it from a JSON file on disk. And Storyplayer's got a module that helps you do that. And it's just a free-form JSON file. And the reason it's a JSON file is so you can commit it to Git. So you can share it amongst your developers. It's not in a database where you don't know what state the user's in at the time. You can always start from a known position when you do a test run. Very easy. And the user that comes back is a PHP standard class. There's no magic there at all. The next thing to do is we may not be the first test running in this test run. So it may have already authenticated. We can't assume it's never authenticated against the API. So let's strip out any authentication information that's been saved from the last time the test was run, just in case. Next part of the story is actually doing the test. Connecting to the API server, getting that access token. And in Storyplayer terms, that's an action. So we had an action function for that. And Storyplayer's got these different phases to guide you through designing a test, so it's structured and relatively rigorous. Nothing worse than unstructured tests for actually producing verifiable results, especially for the team who inherits them. And here's our action. Now let's quickly go through that. So first thing we do, we want to find out where the API server is running. No hard-coded host names in tests. And we'll come back to why in a bit. That's very important. And once we know where we're connecting to, make a HTTP request. To fit it on the screen, I've removed the actual arguments to the HTTP post. And then make sure what we've got back is a 200 OK. We don't want a 401 authorized, a 403 forbidden. We certainly don't want any 500s coming back. That's it. We've now created an access token. We've satisfied the story that we wrote. It's that easy. How many of you do functional testing in your own companies? A few hands. I don't know what kind of test tools you do, but can you do it in that amount of code? Oh, there's some nods there. I'd love to know what tool you're using for that.
Symfony plus PHP unit.
PHP unit?
Yeah.
Ooh, boo, hiss.
And we got the BHAT and framework called Kavan.
Okay,
Kavan uses like aspect syntax.
okay. Right. So you mentioned BHAT, you mentioned using PHP unit, and you mentioned a framework called Kavan, which is aspect-oriented.
Yeah.
Right. So PHP unit is a terrible choice for this. Because PHP unit is designed to actually load your code and execute it at the function level. That's what it's for. It's very good at that. If PHP unit's doing functional tests, but you're trying to ship code by making sure your unit tests run, your developers are sat there waiting for things to happen. It's a real problem. That's actually the unit test suite we inherited on this project. At one point, that unit test suite was taking 5 hours to run, which makes the shipping, it's not shipping faster, it's not shipping at all. It takes a whole day to run your unit test effectively. You can't ship, it's just terrible. BHAT is an example of a BDD tool. If you look at the Cucumber community, who are years ahead of us in their practices, and is one of the places where BDD has really come from, they have moved away from this type of testing, especially with the testing I'm about to show you in a minute. BDD tools are not precise enough without a lot of effort to do that well. It doesn't scale. I have personally seen projects with BDD coming out your ears. Shipped it, customers couldn't use it. It's not precise enough to deal with large scale well. It's very good for acceptance testing, very good for getting invoices signed, but for shipping working code, there's too many gaps. It's not what BDD is really good for. Which is why 3 years ago I came here and actually introduced Storyplayer and said it fell between those two tools. And today I believe that more strongly than I did at the time. But coming back to our story for a minute, I mentioned earlier that we're a bunch of mad scientists. And part of science is verifying that something has happened. Just because the code is run doesn't mean anything's happened. There was a tweet going around earlier this week about don't trust a test that has never failed. I don't know if any of you saw that. Just because a test runs doesn't mean anything's happened. You need to verify it. And if we look at our story has some implicitness in it, which is not a very good story. It's implying that the token will allow us to use the new API. But it doesn't state that explicitly. It's implicit in the English. And we haven't proved that the token's any good. Just because we've got a result back doesn't mean it works. So we need to prove that. So the first thing to do is to extend the story and take that implicitness out and make it explicit. I mentioned in the architecture how the state of the server is actually stored in MySQL. So log into the database, have a look, make sure the token's in the database. As an aside, we discovered that with this server actually deletes the access tokens from the database. There's a class of operation we didn't know about when we took this project on, where the tokens are one-time use, and the moment you've used the token, it goes and deletes it. And we only found that because we were writing tests that looked in the database to make sure the access token was there. We didn't spot that otherwise. And we should actually use the token to prove that you can talk to the API. Storyplayer has a phase for that. It's the PostTest Inspection. Now, before I show you what the PostTest Inspection, we actually need to share some state between some of these phases. And to do that, because you may have noticed that the anonymous functions that you're writing in Storyplayer, they've got no inputs. There's no input parameters. They don't return anything. That was a deliberate design decision when we built Storyplayer. Storyplayer was built both for devs and testers alike. Testers often aren't very strong programmers. And state in code is a source of a lot of bugs. You could argue it's the source of most bugs, implementing the wrong algorithm being the rest. And if you've got test tools that store state, especially if the test tools are driven by magic, so you can't even see that state, for a tester trying to debug a test and get a test working reliably is a huge time sink. You can waste days on that. I've seen people do it. And we want to ship faster, not slower. So Storyplayer, state has to be explicit. Very deliberate design decision. And to do that, there's an object called the checkpoint, which you can get and set inside each of these stages. And that's what we're going to do. We're going to extend the action. We're going to get the checkpoint, and the checkpoint is just another PHP standard class. And we're going to store the result in there. And then in our post-test inspection, we're going to share that state by explicitly pulling out of the checkpoint. So anyone who's reading that test, who's used to using Storyplayer, knows what state is being passed around. There's no surprises to anyone reading the code at all, which makes the tests much quicker to write, much quicker to maintain, and much easier when you pass it on from person to person. You have to assume that someone else is going to inherit your results and have to maintain and live with it. And after that, decode the contents of the result, make sure it's valid JSON, make sure it's got the access token, and update our user object to say, OK, now we've got a new access token. And Storyplayer ships with some modules to do assertions on data. It was originally written for PHP 5.3. And PHP 5.3, lots of fatal errors, runtime errors, where the whole PHP runtime would crash, and your code couldn't catch it, couldn't recover from it. PHP 7 started to address this. As someone like myself who writes highly robust code, PHP 7 still has a long way to go compared to other languages, but it is going in the right direction. But that's why you have to check your data first. So that's proven we've got an access token. Doesn't tell us it actually does anything. So we can add another post-test inspection for that. And again, the code's all very similar. Very simple, very easy to read. It's pure PHP. There's no DSL to learn. All you've got to do is have the manual open with all the list of modules and the methods available on it, or use an IDE with code completion, and you're sorted. And you'd write another one as well to actually check the database. You'd actually make a PDO connection to the database, look in the database table, and make sure the token's there to satisfy the test. So just to recap, you've got these 3 phases. Test setup, make sure your preconditions are created and that they're met. And action, perform the test. This is the thing you're proving works. Then afterwards, verify. Make sure that what's happened has actually happened. 3 things. That's the format all stories that Storyplayer animates runs. You can teach this to people within half a day. How long did it take you to learn it, Craig?
Probably about half a day.
About half a day. And then they can write their own tests. I get developers who work for me to write their tests. So as we're moving along, we're building up this test suite. And that allows you, once you've established this point, it allows you to move on, break out of the beachhead by building up the tests, one feature at a time, one scenario at a time. And that's exactly what we did. We wrote tests just like the one you've seen. The Storyplayer would talk to the payment service, it would query MySQL, make sure everything was what you expected. As the queue workers became built, started to work, it would run those. It would actually stand them up as a process, feed data in and make sure the right data was coming out. Not like a unit test where you are actually including code into your code and running it. Run it as a separate process. Make sure it didn't crash. Make sure it was actually polling for data. These are things that with unit tests, you often end up mocking at the edge of your application in order to make them work. Mocks are lies. Don't use mocks unless you absolutely have to. We would simulate being a payment provider. So we would actually generate a simulated event from the bank and show that it flowed through the system and came out at the queue workers at the other end. So that we knew that the messages that we were expecting to receive, which we were pulling off the logs from production, and then anonymizing, of course, would actually work. So we were proving the whole thing worked end to end. So as we were writing the code, we knew that the APIs we were creating worked. And I mentioned the API client. So we actually stood that up as well. We imported that Zend Framework module. See, the API client is used by other suppliers. And the last thing we wanted to do was disrupt their delivery schedule by shipping them a client that wasn't well tested. And again, because the client has to consume data that ultimately comes from the banks, we want to know that it works end to end. Yes, you can use mocks to simulate some of this, but when I finally handed that client over to the other suppliers, I knew they could import that code, they were going to run it, they were going to have 0 issues. Unit testing with mocks does not give me the same confidence, never has. What it means, if we look at our architecture, is what we ended up building up was coverage over quite a lot of it. We ended up having coverage over the API client, coverage over the new modules in the payment service. We weren't going back and writing many tests for the existing functionality. We weren't there to change the existing functionality, we were there to extend the application. The new queue workers, very good coverage. We had to go back and update those and add encryption and message signing in order to get the authority to operate the service. That was just another test that we had to drop into what we already had. We knew that the data was being written to MySQL. It had the right content in, the right format in, nothing getting missed. And Storyplayer uses Selenium exclusively for powering browsers. So we had a couple of tests as well that exercised the very limited user interface that the payment service provided. It was little more than a health page to say, hello, I'm up, everything's working. It's a little more than that. But we had that as well. And that's what we were building as we were moving along towards this Christmas deadline. Now, I want to explain to you why we took this approach, why it helps ship faster. I want to introduce you to the dev test dance. If anyone's got a better name for it, I'm going to steal it, but that's the best I could come up with while I was writing this talk. Someone develops code. They ship the code. It might be to an internal test team, it might be out to the outside world. Someone uses the code, they test it. How many of you have dedicated testers? Hardly anybody. There's a few hands, but hardly anybody. Do you have product owners testing your code? Okay. How many of you is your customer the first person who tests the code? Okay, so there's quite a few hands not gone up at all. So who is testing your code then? If you've got no one inside the company using it, and your users aren't the first person to use it, what am I missing? Who else is testing your code? Developers, okay, right. But the problem is ship the code, and the developer's off doing something else. They're off onto the next task. That code's been and gone. Now, often rework is required with code. It has to come back. It's not right first time for whatever reason. It has to come back to developer. How many of you are familiar with the meme that if you want to interrupt a developer, you should assume you're inviting her to a meeting that's 2 hours away? Yeah? No? A lot of blank faces there. So that's a popular meme, and that's based on the way the brain switches between tasks and the amount of cognitive load you can hold in your mind at any one time. There's a lot more research into this than I want to go into tonight. But the thing is, if you're working on a new feature and then you've got to come back and fix your old feature because you finally got some feedback on it from somebody, you're interrupted. And those interruptions tend to stack up. It doesn't tend to be one interruption. It tends to be 2, 3, 4, 5, 6 until you lose track of things. And it results in poorer quality work because you're constantly context switching in your mind. You're not keeping everything in mind. Things easily fall off the table. They get forgotten about, and the cycle perpetuates. And often this cycle appears in companies with bad practices anyway. So it's not just the developer being bad, it's a whole system thing. Now that whole thing of it spinning round and round kind of reminds me of something else. It reminds me of that. This is what your business sees. Your business owner, your product owner, those of you who are developers delivering to a business unit of any kind. Development's a sausage machine to them. They spend money on raw ingredients. It goes in one end. But there's no sausage coming out the other end. They want to sell the sausage, but there's no sausage. And then eventually, something comes out, and they look at that and they go, I can't sell that. And it has to go back. And all the time, for the business, it's like there's an hourglass just sat there spinning round and round for them. The time it takes to design and develop working software is the biggest cost to businesses today. Stop the dance. It's what shipping faster with Storyplayer allows you to do. You want to get into a tight loop where you're testing your code, validating its design over and over and over, so that eventually you can ship the code and move on to the next item knowing you're not going to be interrupted unless someone's asked you to build the wrong thing. No test in the world can help you if ultimately you've been asked to build something that was a bad idea. Nothing can help you with that. But as long as you've been asked to build the right thing, you can do that. Now, this iteration thing is very important. I don't know how many of you actually follow me on GitHub and follow my stuff. I know I've got some followers. When you see me tag something in GitHub as version 1 of something, that's not true. I'm iterating over and over and over. I might iterate 3 or 4 times an hour on a design until I've got something I'm happy with, because I'm writing Storyplayer tests that use the product, use the API in the way it's going to be used once it's shipped. So if I'm modeling an API, I start off with a design on paper, I've brainstormed it on a whiteboard, but once I start writing code to interact with it, and I've built the whole life cycle up, you tend to find designs change. It's the old story about wars, about no plan survives contact with the enemy. Same sort of idea. Tight loops. But when it ships, it stays shipped. I've moved on to the next thing. I haven't had to go back, because going back is incredibly expensive. Allows me to ship faster. Allowed my team to ship faster. by the time we were merging, we were proving that the features worked. We had empirical proof for that. Because we were using the features in the same way as the end user. We'd iterated over and over and over to make sure what we were merging was right, and allowed us to ship and move on to the next feature. You ship it, you move on. You ship it, you move on. And once you get that into a habit, you build velocity on the project. And there's no greater feeling on a project than velocity, especially when you've got a hard deadline that you have to hit. It's joys of fixed price projects. But the thing is, you can maintain that velocity once you're going, because you're actually building a regression test suite as you're going along. So as people leave the project, new people join the project, you're proving that the new people aren't making things worse. They're actually making things better, which is what you've hired them to do. And this is a lovely one for me. Avoiding the whole works on my laptop syndrome. Now, the project we'd inherited suffered from that syndrome. We'd inherited it from another small team, a different supplier, and it was all built around their lead developer. Everything went through them, everything worked on his laptop, and only his laptop. So you couldn't ship his laptop to prod because he was rolling off the project and he was kind of fond of his laptop and wasn't going to give it up. So by using Storyplayer, as part of our merge process, if I wrote some code, Craig wouldn't accept the merge request until he'd actually seen the code run on his machine by running the tests and verifying the output. So we proved that there was nothing left behind on my laptop. I wasn't doing anything weird with my environment setup that would stop the code running anywhere else. We were building confidence. And that process, first time we do it, it's a little slow, especially if you've not done it before, because it takes time to get used to it. But at one point, we were doing 3, 4, 5 merge requests a day across the team of 3 of us. We were starting to get some real velocity. So things were going well. But every good story has a plot twist, and so does this one. This was our original plan. We were talking about where code lives. We were going to integrate with version 2 and ship version 2. Version 2 was being developed by a different supplier, different team to us. One Monday afternoon, whilst I was traveling back from a meeting, they sent an email out saying, unfortunately, plans have changed. We've got to go into beta. We can't ship your code as part of that. You've got to move your code into version 1. Oh, and by the way, we're deleting all your code as well. You've got 30 minutes to save it. And I'm in the car. I found out about this when I got home at the end of the day. They had to delete the code. It sounds terrible. I want to defend them here. Our project standards say you only ship code you're using. Security for this particular environment, this particular platform is very important. And so there was a requirement on them by our mutual client. Code's not being used, gets deleted from the database. They had to ship before we were finished, so they had to delete our code. So we had to move it. Now, I don't know about you, but for a lot of people, all of a sudden having to recreate your results in a different code base with no warning, and the deadline doesn't move, by the way, because it's a fixed price project, you've still got to do it because the cache is burning. That, for a lot of teams, is quite a challenge. How many of you think you'd be comfortable having to do that? Okay, I'm not seeing a single hand. Maybe I'm missing one, but everyone there is looking very bad. It's not a problem. We're already shipping faster. We already had ways to prove that what we wrote worked. And we had practices that said, you have to verify everything's working on more than one machine, which meant because of Git being distributed, we all had copies of the code. It didn't matter that the other supplier had been forced to delete our work. We already had it. All we had to do was pick it up, put it back, run our test suite to find the things we'd missed, because the payment service is actually made of a number of composer modules. It breaks down in that. It's not a single monolith. Just picked it up and moved it. Takes time, but if you've got some way of proving that you can do it, it's not that stressful. It's not that stressful. It's a bit of a grind, but that's life. So we ended up with this situation where we were now integrating with version 1 because version 2 was going into beta, and our stuff had to be stripped out. And we'd have to, or some supplier would have to build a version 3 to bring it all back together, because you've got 2 diverging code bases now with different functionality. And at some point, someone would have to bring in version 3. And that would eventually allow us to get rid of version 1, get rid of version 2, they're separate deployments in separate infrastructures, bring it all together into one infrastructure, and verify our merge was complete. That is where I'm going to leave the story for the moment. Storyplayer allowed us to get to the point where this is something we've been able to tackle since Christmas. And the reason I'm going to leave the story is because I want to talk about test environments. Storyplayer is open source, it's free to download, it's free to use, but because it's hitting your system like a user hits it, there is a cost, and it stresses your hardware a little bit. Browsers are big and fat. Firefox is the one we're using. You don't get much fatter than that, do they? Unless you download an old version of Mozilla, if it still works. Chrome's getting fatter by the day. Vivaldi looks interesting. I don't know if it's got a WebDriver module yet. I haven't tried that. But the other thing is, I always encourage people to test the app in a representative environment. I'm here using a Mac to do my presentation. Most developers these days have Macs because they make the best laptops in terms of pure hardware. They're really good at the hardware side of things. Doesn't matter whether you like OS X or not, the hardware side of it is first class. It really is. Anyone who follows me on Twitter will know the fun I've had buying my first non-Mac for a decade. Go look at those tweets and forgive my language. Very unimpressed. But what does representative means? First of all, you want a comparable operating system. OS X is Unix, but it's not Linux. It's FreeBSD. It has a different heritage. Those of you who know your Unixes will know this is more BSD 4.3, 4.4 based, whereas Linux tends to favor System 5 a little bit more. Those of you who know your Unix APIs. You want to make sure you're using the right web server. So you want to make sure you're using the right version of Apache in case you run into any edge cases and bugs. Or if you're using Nginx, you want to make sure you're using the right version. You've certainly got to use the right version of PHP. That is critical, especially in a larger environment where the client is paying a support contract to people like Red Hat for this. And Red Hat makes some very solid stuff, but by God, it's older than I am. It really is. Their packages are ancient. They're really solid, but they're years old. And if you're using, especially if you put PHP 7 on here, and you're using some of the new features, of course your code's not even going to run in production. So you've got to have a representative environment. And I mentioned about the outbound proxy, and it's important to simulate those network restrictions. Because otherwise, you're downloading composer libraries that talk to third-party services, you go to production, and then you find out, oh, it doesn't actually support going through a proxy. You've got a problem after you've shipped your code. Catch your problems first. Now, in terms of this architecture that we've had up earlier, ideally, you want each one of these on a separate box because they're all meant to talk over the network. You don't want any cheating going on. And for years, this has been the staple of running dev environments, especially on OS X. How many of you here use Vagrant and VirtualBox? That's a nice number to see. They've changed our industry. They really have. Two together deserve a lot of praise for what they've done, allowing us to build better quality environments to develop code in and to test code in. Unfortunately, there's a bit of a problem, especially with VirtualBox. It's not the quickest thing in the world. And if you've got a test suite that you're building up that's hitting your virtual machine, you really start to notice this. First of all, building VirtualBox images is painful, especially if you're trying to build boxes on demand. You end up having to go into image maintenance, and all of a sudden you're not shipping faster, you're shipping change requests to another team to update the image if you don't own the image yourself. Absolute pain in the arse. It's really not good. There's no way you can run a cluster like, sorry, too far. There's no way you can run a cluster like that, even on a top spec Mac. If it's only got 16 gig of RAM, it's not enough to run that many virtual machines with VirtualBox. It just can't be done, especially if you're trying to run an IDE as well. IDEs are very, very greedy on RAM and CPU and battery. It's a real problem. Now, Storyplayer acts like a user does, and because it's an API server, it's making network connections, TCP connections, HTTP connections to your API server. These can take seconds to connect with VirtualBox. The networking on this has never been right. It's a real pain. But you end up actually working inside your VirtualBox instead, and at that point, you're starting to cheat and blur the lines of your environment. And unfortunately, although things are a lot better, VirtualBox will still crash your box from time to time, especially if you're hitting it hard. So the problem with this combination is it's practically impossible to run a representative cluster for dev work the moment you're into clusters. It's practically impossible. And it's certainly impossible if you've got to support multiple versions. So at one point, we were supporting the version 1 that was live, the version 1 we were building, the version 2 that was in beta once the other team had rolled off. We took over maintenance for that. And we were starting work on trying to bring it all together into one single version called version 3. 4 different versions. If you're shutting down virtual machines and starting up others to switch between them, we're back to the context switch, the interruption, the difficulty of keeping everything in your head. If it takes you 10 minutes to switch test environments, as a developer, you switch off, you go and do something else. It's a real pain. And if you're trying to do A/B testing side by side, well, just forget it. You just can't do it. Plus, there's another thing to consider. Most firms don't buy people the very best hardware. I'm lucky. I run my own firm. I can have whatever I want because I sign the checks. As long as there's money in the bank, I can have it. So my dev box at home, I'm going to do a blog post about my dev box. It's awesome. Flash-based disks for loading virtual machines really quickly. I can boot a Vagrant box in something like 2 seconds. It's fantastic. But you can only still get 16 gig of RAM in. So you're still limited for how much you can run. You still have to shut stuff down to move it up. The hardware is the limiting factor. So I want to give a shout out to Docker. People who follow me on Twitter know I've been a harsh critic of Docker over the years. I know Paul was here last month to talk about Docker. I'm not going to go into the details of how we use Docker, but I wanted to give them a shout out because we switched to Docker for our dev environments and it helped us ship faster. Docker's very fast to build an environment on demand because of the way it caches things. It's superb for that. I can have all 4 versions running on my machine and not even notice it. All those different environments. 24, 28 machines, all up and running, not a problem. Because the Docker containers, they're not a full machine, they're really lightweight. You don't notice inbound network connections. It's like connecting to Apache running on your local box. All those 2-second delays, which in a test suite, 50, 100 tests, each one making 3 or 4 network connections, you've lost minutes there alone. With Docker, all that goes away, instantaneous. And Docker has never crashed on me, never caused my machine to crash. With the one caveat that I have cheated, I run Linux as my host operating system, not OS X. Docker native is coming for OS X. Fingers crossed that will improve things. We'll have to wait and see. But I want to stand here and say that for development environments, Docker really is a viable option. If you're using Vagrant, if you're using VirtualBox, if you're suffering the performance pain that we had on our project, go use it. And there's a killer feature, which you may not be aware of, that's only been around since Docker 1.9, and that's Docker networks. You can actually create a private network inside your computer and attach containers to it. And you can have multiple networks. So you can have a network with all the machines on for each version. So I've got a network for version 1, I've got a network for version 1.next, version 2, and version 3. Now with most test tools, and this is one of the reasons I'm mentioning all this, is actually switching between all these environments is quite a pain because most tools hard code the hosting that you're going to. With Storyplayer, one of the big improvements we've made since I was here 3 years ago is your test environment's now in a config file. All your hosts are in there. And to run the same tests against a different environment, different set of Docker containers, all running at once, you just change the config file and tell it to load this config file instead. And you don't have to edit your tests at all. Not at all. I can run the same set of tests against every version of the payment service to find out how we're doing. And for shipping faster, that's amazing. The amount of confidence that gives me, because I know those tests are proven. The test environment config is really easy. It's a list of hosts. Each host, you just tag it with the roles that it wants. Multiple hosts can have the same tags so that you can simulate a cluster of 3, cluster of 5, cluster of 10. So if you're doing round robin or you've got a load balancer in your architecture, you can prove that works. And the tests, the way the tests work, so you don't have to edit them, is they do a lookup by host, not by host name. And that allows you to run your tests anywhere. So I run them against the Docker network. One of my colleagues actually runs the code locally and runs the tests against localhost. We run the same tests on Jenkins. We use Jenkins for CI. We run the exact same tests there with 0 editing, 0 modifications. We deploy the code as part of continuous integration. We run our test suite, so we know we've got 3 machines at that point proven to work on. Catch any problems. And anywhere else you want to, Storyplayer doesn't care. If PHP can talk to it, Storyplayer can test it. And all this together allows you to ship code really, really fast. We hit our deadline. December the 18th, I was able to say to the project manager we were code complete, where the code was ready to be shipped to the formal QA process that the client insists on, and eventually out to production. That code went live last night, so a long time from our original deadline. I got a text this morning. I wasn't part of the release. I'm on holiday this week. Didn't log in to see how it went. I got a text this morning from the project manager to say it went in without a hitch. 0 problems at all. And I was so confident of that because of all this work we'd done. Last night, I was in bed, asleep. I wasn't even on call. My phone's in another part of the house. They couldn't have called me if they tried. Because we'd shipped, and I knew we'd shipped. I didn't have any doubt whatsoever. But before we finish, there's one more thing I want to bring up. And it's the reason I put this talk together in the first place. And it's the underlying reason behind why I built Storyplayer and why I'm promoting this way of working. Because I'm an independent contractor these days. If any of you are contractors, I'm in competition with you for work. Why am I sharing with you why I can get these things done? And it's because of this. Ninjas and rock stars. How many of you have seen job adverts with those terms in? Not as many as I expected. How many of you work for firms that write job adverts like this and are willing to admit it? There's a few more nervous people there. So we've been plagued by this. In America, this is out of control and has been for years. And it's a disease that has come across the Atlantic. People asking for ninjas, rock stars, and unicorns. You can even hunt for unicorns online these days if you're a firm looking for staff. I have my head in my hands over those type of job adverts. Can't stand them. Certainly wouldn't apply for any of them. And most of my colleagues who do this kind of thing I do, got my kind of background, my kind of experience, feel the same way. But I've got some sympathy with the people writing these job specs, because underlying all of this is that they are looking for productive developers, and this is the language they're using to try and find them. They're also looking to fill any seat at all, but they want to fill it with someone who's going to be productive. Because remember, time is the biggest cost for delivering and designing software. It's the biggest cost. So you want developers. Developers are now your competitive edge, not just in terms of can you do the work at all, but can you do it for a price? Can you do it for a price so you can win the work off a competitor if you're doing out to tenders? I've been very fortunate. I have been trained by and worked with some amazing world-class level developers throughout my career. And I've been making notes about them and observations. And here are 4 of my favorite ones from these people who have taught me over the last 20-odd years that I've been doing this professionally. They question everything, they verify everything, they check everything, because they want to make sure they're building the right thing. They don't want to spend time building the wrong thing. And they want to do that so they can ship code that works, code that sticks. when I started in the industry, we had a phrase called fit for purpose. I don't hear it used anymore. Another phrase I've often used with my own teams is right first time. I'm a great believer in that. Because you want to avoid the costly rework. That's where your money burns really badly. When instead of using time to get more money in, you're using time on work you've already spent money on. You're spending more money on the same work. Now, this whole thing I've shown you tonight, the whole story about how we delivered this project on time, I call this representative testing. And anyone can do this. You don't have to be a unicorn to do this. You don't have to be a ninja to do this. You don't have to be a rock star to do this. Although I am on, there actually is a PHP rock stars list on Twitter, which Cal has added me to, the bugger. Thank you very much, Cal. But you don't have to be considered one of these people to do this. Anyone can work in this way. On this project, I took 2 people who were DevOps roles. They were part-time developers, part-time infrastructure. They could do both. I taught them this workflow. They used this workflow. They were delivering. In my personal opinion, from the stats available to me from GitLab, they were outperforming the other suppliers by adopting this approach. They'd never used it before, and they had 6 weeks to deliver an entire project, including learning this workflow. And they did it. Storyplayer is the only tool that's built for this workflow. It was invented to support this workflow years ago. And that's why, for me, Storyplayer is the real hero of this story. Thank you very much. Any questions from anybody? There are people with microphones. Oh, here we go. Yes, please.
Hi. Thank you for interesting talk.
Thank you.
So, on your project,
Yep.
what was the balance of functional and unit tests, if you had any?
Because of the unit test situation we inherited, our new code we would write unit tests for, and we made sure they were we use the term proper unit tests inside. Another phrase we use was they were very unity. They would test a single function. There would be multiple tests to prove what it should do. Where we were modifying existing code, as Zend Framework, you can have modules self-contained, but in reality, you end up having common layers between the modules. For those, it was very expensive to try and modify those unit tests, so we were limited in what we did there. And there, we leaned more heavily on Storyplayer tests to give us that same coverage.
Okay, thank you.
Okay. I don't think that's working.
Hello?
Hey,
there we go.
hello.
So I think this is called leading the witness a bit. So with the worker queues,
Yes.
were there any instances where you'd used Storyplayer to find a behavior that we hadn't expected?
Oh dear. I'm not sure how much I can talk about that. We found behaviors, the queuing system, because it's all hosted on Amazon, we were using Amazon SQS for the queues, and that proved some interesting behaviors. I previously worked with ZeroMQ, where the biggest challenge is getting data at all. ZeroMQ is fast, but it trades guarantees in order to be fast. There's no guarantee your data is going to go from A to B. SQS is quite the opposite. What you have there is it guarantees at least once delivery, but what you've got to be able to do is cope with multiple deliveries coming through. And by running our tests against real queues, we were able to see that, even at very low volumes. And we were able to share that experience with the other suppliers as well, to say, look, we're all new to the SQS. Here's what we're learning. We want to share this with you so that you can also ship on time. And by the way, here's how we prove that. Here's how we verify that, so you don't have to go through the exact same cycle and duplicate all the effort. So that's an example there.
Thank you.
Okay, who's next? Ooh. Any more questions? No? Yep. Oh, sorry.
In unit tests, there are test coverages.
Yes.
Do you have something similar in Storyplayer?
Not at the minute, no. Apologies to Derek. Xdebug is slow as molasses when you're running a heavy test suite because of the work it has to do. I'm very interested in playing with a new PHP debug module that ships with PHP 7. I've done some playing around with PHP Unit to use that to generate, because PHP Unit now supports that as well, to generate code coverage, and everything runs much faster. So I'm interested in doing some work with that to see with Storyplayer whether we can generate test coverage as well. Because I'm mindful it is a gap. I am a great believer in at least 100% coverage. I describe my tests as 300–400% coverage, is how I describe mine. That's a talk for a different day, so I don't really want to go on that. But I assume we're going to a pub or something afterwards. If you want to badger me about that, please do. I can talk about that all day. Any more questions? Oh, yes, please, at the front.
I'm sorry, but for like coming from somebody that would like start an app, what kind of advice would you actually make? For somebody that would like to start up a startup with an app business? Start
with an app business. I think that's another one for the pub. Come and talk to me in the pub and we'll definitely answer that for you.
Okay, thank you. Thank you.
Okay. Oh, at the back, please.